With that done, we are ready to move into a CopNet. We import the hair geometry, rasterize the setup and select the UV space. So COPS will take the information from the 00 to 11 coordinate space, exactly what we need for the texture generation. Then, with the help of rasterized GeoNode, we extract all the data we need for texture map baking. These are Z depth, alpha, anisotropy for karma, curve U for root map, and roughness. All of them we import as monochannels. Then anisotropy for Unreal Engine as a color map. And ID as ID. This is integer data that is automatically interpreted in COPS as a color map. Here you can see the full range of texture maps I am baking: ambient occlusion, normal, depth, anisotropy for karma and Unreal Engine, roughness, ID, and root map. Let's take a look a bit more thoroughly. The Z-depth part of the network is the busiest, because we use this data to generate three maps: height, normal, and ambient occlusion. For the height map, I use a ramp node to remap the depth. Here I need to invert the data and compress it slightly. I adjust the side sliders so that all the hairs are lighter than the background, and position the central slider to provide enough contrast to the image. Next, I use a streak blur node to blur the hair textures vertically. This helps soften the pixelation at the ends of the hairs. I use the height map then to create both the ambient occlusion and the normal maps. I take height to ambient occlusion to generate the ambient occlusion map, and I take height to normal to generate the normal map. While preparing the alpha map, I also apply a streak blur to soften the appearance of the hair at the ends and roots. As you can notice, I do this for all the mono channels here. I turn ID to the color information with the help of ID to RGB node and output anisotropy maps without any changes. Finally, I render everything using the rope nodes. Organizing them this way makes it simple to render everything at once. Boom! Done. I don't generate a diffuse map here because I prefer to create it at the shader level using the ambient occlusion map, root map, and ID map. By mixing these in different ways, we can achieve a variety of results. Now let's take a look at how we apply these textures. Here is my setup for a hair card. We start by generating a line or drawing a curve, ensuring the point order is directed upside down. Then we sweep it with a ribbon. To ensure the ribbon has the correct width, we need to know the width of the original plate for that particular hair strand. We obtain this parameter using a measure node, which measures the perimeters of the primitives the lines were broken into. Code for this is quite simple. Next, we use the sweep node to create UV texture coordinates. We then adjust the UV coordinates of the card based on its type. Again, we use some VEX code here to adjust the texture coordinates using data from the initial lines. The principle is simple. If the number of the strand type is less than the number of the point on the first row line, then we can place the current card within the Y space of the first row. If the number is bigger, it means that the strand belongs to a second row of hair cards and we need to place it within the Y space of the second row. And we also extract the X position data to assign proper X coordinates to our hair cards. As a bonus feature, I included a ramp to manipulate the V coordinate of the texture. This allows us to change the card's appearance without altering the texture itself, which can be helpful when dealing with the texture repetitions. As a result, we can now easily adjust the card by moving a slider. Of course, it would be more convenient to pack all these nodes into a subnet, like this. To keep the node network tidy and avoid this kind of spaghetti for each hair card node, we group and pack all the necessary data and then bring it into the subnet using the object merge node. Inside the strand subnet, we retrieve this data, split it, and use it within the node tree. I've promoted several key parameters, allowing for easy manipulation of a strand's appearance. In the SOP context, these textures look quite chunky and rough. Let's take a look at how they appear in Karma. You can see here how the anisotropy effect works on the hair strand. Building this kind of shader is a separate topic that I won't cover today. With that, I will conclude this tutorial. In the future, I plan to show my methods for placing hair cards in Houdini. Stay tuned and you won't miss it. I hope this was helpful. If you have any questions or feedback, please don't hesitate to share them in the comments. I will gladly answer what I can. Thank you for watching and goodbye.